Okay, 7.4, it says you'll look at how changes in one variable and a function of several variables will affect the values of the function. So in other words, you'll find the rate of change, which is derivative, of a function with respect to one of the independent variables. So to do this, you're going to have to find the partial derivatives of the function. So you're going to see things like find the partial derivatives, or down here, find the first partial derivatives. So here, partial differentiation means that you will find the derivative of the function with respect to one of the independent variables while you hold the other variables constant. Okay, so if you're holding the other variables constant, you're going to treat them as a constant. Pretend they're numbers, okay? And when you take the derivative, just pretend those other pieces are numbers, okay? Then it's not too bad. So this is the notation that you're going to see as you're doing this. Okay, this first one here is how I say it, dz dx. So it's the partial of z with respect to x. So you're taking the derivative of your z function, and your x is your independent variable. So what do you do with the y's for this? You just treat them as a number, okay? So for this here, if we're finding dz dx, we're going to think of y as a constant. Okay, how about this one, dz dy? What do you think you're going to do? Yeah, you just treat x like a constant. So let's look at the other notation here. So that's the dz dy. It's with respect to y. This here is another way it might be written, with this f with a little x. That means it's the partial with respect to x. So this one is with x, this one's with x, and then this is also the derivative with respect to x. And then these other ones are ways that you can say take the derivative with respect to y. Okay? So these three are the same as each other, and then the y ones, they're the same as each other. It's just written differently depending on the problem. So let's try the first one and see what happens here. Okay, so find the derivative with respect to x. So instead of z, I'm going to write dz dx. Okay, now 2x squared. If I'm taking the derivative with respect to x, what's the derivative of 2x squared? 4x. Now, what are all the constants in this second term? 4y cubed. Don't I just leave the constant out front? Okay, so let's just write this as 4y cubed, and then the derivative of my independent variable x squared is 2x. So you leave the constant out front, and then you take the derivative of the variable. Does that make sense to everyone? Okay, in this back piece, what's a constant? The whole thing is, right? So if I take the derivative of a constant, I get 0. Because your y's are constants, right? So think of this as like 3 squared. The derivative of 3 squared would be 0, right? So maybe write that in your notes so you don't forget where it went. And then just trying to, I guess, clean it up here. This turns into just 4x plus what? 8xy cubed. Okay, so that would be my partial derivative there with respect to x. We're going to use the same function here and take the derivative with respect to y. So what is the derivative of 2x squared? 0, because it's all constants, right? X is your constant now. So I have 0 plus, what are my constants in this next term? 4x squared, so they stay out front. And the derivative of the y cubed is 3y squared. And then the back is going to be plus 2y. And then we just clean it up a little bit. So we've got 12x squared y squared plus 2y. So any questions on that? Do you see how it's pretty easy, but do you see how easy it would be to mess something up if you're not very careful with them? Okay, now down here it says Find the first partial derivatives of this function here and evaluate each. So you have to find both of the partial derivatives. How I would write this, because it's f of xy, is like this here. Okay, these middle ones. So if I'm finding the partial derivative with respect to x, we would write it like this. And I'll let you guys try that one. And then go ahead and find the partial derivative with respect to y. And find that one. And then you can try to evaluate those at the point given. So I'll give you guys a minute to try that before I just show you it. So a lot of you, I think, will know what to do there. So if I'm taking the derivative with respect to x, the y cubed is constant, and the derivative of x squared just turns into 2x. So really I have 2x times y cubed. And then down here, the derivative with respect to y, the x squared is constant, and the derivative of y cubed would be 3y squared, so we end up with 3x squared y squared. Does that look okay to everybody? And then you're just plugging in this point. So if I plug 1 in for x, that's not going to change this at all, so it's still just a 2. And 2 in for y, I get 2 times 2 cubed, which is 16. Is that what you guys had? Okay. And then down here, you plug 1 in for x, that doesn't do anything. 2 in for y will give me 12. So, questions on that? It's really not that bad, right? Well, let's keep going. Okay, so the partial derivative is the slope in the x direction. What do you notice about this here? Which partial derivative is the slope in the x direction? The x, right? And then the partial derivative with respect to y is the slope in the y direction. So when it says find the slopes in the x direction and y direction, you just do what you would think you would have to do here. So let's start with the x direction. So I'm going to find the derivative with respect to x here. And it's what? X, y. Okay, and we're trying to find it at this point, 1, negative 149. So it's actually x, y, and z that I'm given there. Okay, and if I take the derivative of this with respect to x, what do I end up with? 8x, and what happens to the rest? It all goes away. This is 0 and this is 0, right, because they're constants. So then we want to actually find what it is at this point. So we'll find it at 1, negative 1, and 49. So what do I get if I plug in 1 for x, negative 1 for y, and 49 for z? 8, right? So it's just 8. So that's your slope in the x direction. Like your rise over run. Coming out at you is the x direction. Okay. Now in the y direction, you don't really have to interpret these, which is nice, because it would be very hard to like visualize. You just have to be able to find them, so that makes it a little bit less stressful here. So go ahead and try the y direction here. What are we getting for derivative? 18y. And then we're finding it at this point. Oops, it's positive one first. And so really we're just plugging negative 1 in, so we get negative 18. Okay, so we can extend this past just the x and the y. We can do like w equals x squared y, natural log x times z. So now we have our 3 independent variables here. So if it says find the 3 partial derivatives, what are the 3 partial derivatives going to be? Yeah, y, x, y, and z. So instead of dz dx, what will we write for the first one? Yeah, it's going to be dw dx. Okay, so we'll find this, then we'll find dw dy, and then the last one will be dw dz. Now, some of you are still forgetting to do this when you take a test and do your derivatives. What do you think I have to use on this? Product rule. Do you see how there's an x, there's more than one x? So I would split them up so that your product involves an x in each of them. So I would just have that be my first piece and this be my second piece. Because when I take the derivative of this, one of them's constant anyways, right? Okay. So if I'm taking the derivative with respect to x, what is the derivative of x squared y? 2xy. And then you leave the back one alone, right? Whoops, I almost put y there. Okay, so that's the derivative of the front and leaving the back alone. Then what do I do? Plus, leave the x squared y alone. And the derivative of natural log of something is 1 over that something times g prime. Like it's g prime over g, right? This is your g here. So if I take the derivative of xz, what would I get? Try again. Z. That's where you have to be really careful. Okay, think of this as, which one's constant in here? Z. So think of this as x times 3. What's the derivative of that? 3, right? So do you see how the derivative of this would be z? So it's the constant piece. And then you divide by x times z. So I would just start, I would write it out like this just so you're careful with it. A lot of you make mistakes, and it's hard to give you partial credit when I can't see where the mistakes are made, you know? So, yep, this doesn't need changed at all, so we still have that 2xy natural log of xz. And then back here, the z's are canceling, and what else? And x. This x will cancel with one of those, so really I'm just left with xy. And don't worry about trying to factor stuff out and those type of things. Just leave it like this. Obviously, you could if you needed to, but... Questions on that? I'm going to let you try the other two, and then we'll do them together in a couple minutes. Okay, so if I'm taking the derivative with respect to y, it gets a little bit trickier here. So with respect to y, my x squared is constant, right? So what's the derivative of this front piece? Just the x squared, right? So we have x squared, and then I leave the back alone. So most of the time people get that part of this right. Not if you know what's going to happen here, but a lot of people don't see it right away, okay? And then back here we leave the front piece alone. And the back piece, they're both constants in here, right? So when you do g prime, what do you get? 0. So it's like a 0 over xz. So that's how a lot of people end up writing it. This whole thing then goes away, right? So then all you have is just x squared natural log of xz. So if you looked at this right at the beginning, you might have noticed that the only thing that's a variable is the little y that's here, right? Everything else is a constant. So you could have just pulled the x squared natural log of xz out, the constant, and then just taken the derivative of y, which was 1. So you may have seen it like that. A lot of people don't see it like that because we're doing the product rule for the first one, so then you just continue with that. Either way, you should get the same thing, okay? So any questions on that one? How many people had it right? Not bad. Okay, let's look at the last one here. So with respect to z, do I have z in both of these? No, so you could kind of do like what we did before where you just pull the constant out front. So what's the constant of this piece? X squared y. So you could just pull the x squared y out front. And then take the derivative of this. If you do the product rule, that, you know, one piece will just go away. So it ends up working out fine. The derivative of natural log of something is the derivative, like g prime over g. So my g is this. What's g prime? What's the derivative of this with respect to z? X. And then that reduces, right? So this x will cancel with that x, so I'm just left with x squared y over z. Questions? Yep. Did you do the product rule?
We did the x over x.
Oh, you did this part here, but you didn't do that? Yeah, the constant just gets pulled out front, so don't lose the constant. If you do the product rule, the constant will get lost with one of the pieces, but not with the other piece, okay? All right. Now they get a little trickier, okay? But it's the same process. That's why I'm saying you have to be very careful with your work, okay? So here we're talking higher order partial derivatives. So do you guys remember what higher order derivatives meant? Yeah, you're taking the derivative of a derivative, right? So maybe like the second derivative or third derivative, those type of things. So that's what we're going to do here, okay? What this first one is, do you see how it says f of xx or f sub xx? That means you take the derivative with respect to x, and then you take the derivative again with respect to x, okay? So it's the second partial derivative of f with respect to x. So f sub y would be, you know, two partial derivatives of y. Do you see how these are the same thing as those? Okay, so these are just the x's here, and these ones are just the y's here. Okay, so it's saying the same thing 3 times. It's just showing you the different notation. Now here is where you have to be careful. Okay, mixed partial derivatives. Here it's saying, okay, f sub xy. So you're going to have to take the derivative of both, right, with respect to x and with respect to y. Which one you do first is where you have to be careful. So you're going to take it with respect to x and then y. So you do whatever comes first, take that derivative first, and then do the second one next. So with the second piece, we do what first? The y first, and then take your answer and do it with respect to x. Okay, so those are pretty straightforward because they list them in the right order. Y or what? Because we haven't taken the derivative yet. This is just the function. When you start taking the derivative, you add those in. Okay, so I'll show you the notation when we get down here. Okay, this here, when it says d squared z, it means the second derivative of your function z, and then it's dy dx. So we do with respect to x first and then y. Do you see how this looks kind of backwards? Okay, so that's where you just have to be careful. Notice x is done first for this one, and here y is done first. So that maybe if you're checking some answers and you have them wrong, maybe you flipped which one you did first or something there. It's possible. Or maybe you just messed something up. Okay, so questions on the notation before we start? Okay, so here it says find the second partial derivative. So that means we have to find how many derivatives? Find the second partial derivatives. So we need to find 2 derivatives for each problem, okay? So the first one that we have to find is f sub xx. Okay, so we're going to take the derivative of x and then do it again. Okay, then the next one we would have to find would be f sub xy or yy. It's up to you what order to go in, but I need that one. What's another one I need? Yy. And the other one is? So xx, xy, yy, and yx. Okay, so let's just start with the top one here. So if I take the first derivative with respect to x, I still am going to need to take another derivative. So I'm just going to write I need to take another derivative with respect to x, just so my notation's correct. Okay, taking the derivative of this with respect to x, what's constant in the first piece? 4y squared, and the derivative of x squared is 2x. So what do I end up with? 8x y squared. Does that look right? Okay, the derivative of the 2x is 2. And the derivative of the 4y squared is 0. Wouldn't that also be the first step for this one? Okay, but what I'm going to have to do to it is take the derivative with respect to y when I'm done with it. So let's just write that down so that I don't have to do that piece again. Okay, so now we're going to take the derivative of this with respect to x again. So the derivative of this with respect to x is going to give me 8y squared. Okay, now here I'm going to take the derivative with respect to y. So the constant here is 8x, and the derivative of y squared is 2y, so I get 16xy. Questions on that? Okay, go ahead and find the yy and the yx. Okay, so I'm going to take the derivative with respect to y first. So that 4x squared is your constant, and the derivative of the y squared is 2y. So that turns into 8x squared y. That look okay to everyone? And then the derivative of the 2x is what? 0, because it's all constant. And the derivative of this back here will give me 8y. So that's going to be the same thing for the first step here. Now the difference, this one I'm going to take derivative with respect to y again. So this 8x squared is constant, and the derivative of y is 1, and then plus 8. Does that look right to people? Okay, now this one I'm doing with respect to x. So the 8y is the constant, and the derivative of the x squared is 2x, so I end up with 16xy. And what's the derivative of 8y? 0, because it's with respect to x. Does everyone see where they made errors or have any questions here? You ready to go on? Okay, you ready for the back page? Guys will, the last page. Yeah. My back page, yeah. Yep. Okay, now this one here, what's the difference between this one and the last one? There's another variable. So when it says find the second partial derivatives, how many am I going to have total? More. 9. Okay, so let's start listing them so we don't miss one, okay? So we obviously have our xx, our xy, our xz, good. Okay, the next one, we can do yy, then yx, and then yz, and then zz, and then zx, and then zy. Okay, so I guess let's get started. So if you guys want to go ahead and start the first one there. Okay, so taking the derivative with respect to x first. I'm going to kind of do it over here and then just write the simplified form over here. With this here, do I have to do product rule? Not really, because neither piece has like the same variable that repeats, right? So when I'm taking the derivative with respect to x, what's constant? E to the y, and then the derivative of x is 1. So it would just be e to the y, right? Okay, now here, do I have to do product rule? No. And if I'm doing it with respect to x, what's the constant? 2z, and the derivative of x is 1. So I just have plus 2z. And then the back piece turns into 0. Now, this is just the first derivative here, but can't I repeat that for all the first 3 here? So I'm going to put it in all of these spots. And then it gets pretty quick for some of this stuff here. So this one now I'm doing with respect to x again. What's true about all of that? It's 0. Okay, it's all constant now, right? Okay, now here it's with respect to y. So e to the y is going to turn into e to the y. And then the 2z turns into 0. So questions on that at all? Okay, and this is with respect to z, so e to the y is constant, so it goes away, and 2z turns into 2. Okay, now this one changes. We're doing with respect to y first. So with respect to y, the x is constant, and e to the y is e to the y. So that's my first piece here. The derivative of 2xz is going to be 0, because there's no y there. And the derivative of y squared is 2y. So that's going to be the same for these next three that we have written. The constant just hangs out front, right? Like if it was 2e to the y, wouldn't it be 2e to the y? Does that make sense? Okay. It's hard because there are, letters in there. Okay, so let's take the derivative of this now. With respect to y, this turns into, this is e to the y, and the constant just stays. So x e to the y plus 2. Okay, now we're doing it with respect to x. So what's constant in this? What's constant? E to the y, and the derivative of x is 1. And then the 2y is 0. So any questions on that? Okay, and then the next one here with respect to z is going to be 0. Questions there? Are we feeling okay with that? Okay, so down here with respect to z, what's going to happen to this first chunk? 0. The second chunk? 2x is your constant. And the last piece? 0. So this is the easiest one out of them. So what happens when I take the derivative with respect to z? 0. Take the derivative with respect to x? 2. And take the derivative with respect to y? 0. Questions? Of just the first part? Yep. So if we're taking the derivative with respect to z, this is all constant, right? So the derivative of that's 0. This is all constant, so the derivative of that's 0. And then the derivative here, the constant piece is your 2x, and the derivative of z is 1. Yep. Okay. Questions? Are we okay with that? Okay, you might end up, doing some of them wrong. Just go back and try to see where you went wrong, okay? So your homework here, you got a lot of problems there. And there you go.